Good morning, class. This session is being recorded, and again, for the privacy issue, you want to mute your audio video. Do not put anything in the chat. You can even change your name to your initials. When I ask you a question, if you want to participate, you're more than welcome to do that, but remember it's being recorded. It's absolutely up to you. So we are looking at section 3.3, basic differentiation formulas. We already have covered the first two sections, derivatives and rates of change, and the derivative as a function. So we're going to move on from here on. So first, we looked at the basic and good old slope when 2 points are given. So in this example, we have 2 points. That gives this blue line, which we call it a secant line, okay, because it contains 2 points on a curve. And if you write the equation of a slope, rise over run, there are different ways of writing it. If the first point is A and we go h units to the right, becomes A plus h, we use this formula. If this one, we call it B, we use this formula. If we call it X, use this formula. All of them really give you the same concept, which is the basic slope of a line. Now, what happens if we move on and we try to make this secant line closer and closer to this red line, which is a tangent line? As we move Q closer and closer to P, the slope of a secant line gets closer and closer to the slope of a tangent line. And that's what we are discussing here. M of tangent line is the limit of M of PQ, which is a CQ, PQ, which is the slope of a secant line as Q approaches P. And that's exactly what this figure is giving us. And if we use this one, limit of the expression as X approaches A, if we use this one, the limit of this expression as h approaches 0. And in general, we call it f prime at point A, the limit of f of x minus f of a over x minus as x approaches A, or the limit of f of a plus h minus f of a over h as h approaches 0. And of course, we can come up with the equation of a tangent line. This is the good old slope, point slope formula, okay, class? So that means y minus y1 equals m times x minus x sub 1. It's the repeat of the same thing we've seen. So f of a is y1, f prime of a is m, and a is x sub 1. And then we said, okay, the general format, instead of a, we're going to use x. This is the differentiation formula. So this is the slope of a tangent line as at a. This is the derivative function. And in Leibniz notation, dy dx is the limit of delta y over delta x as delta x approaches 0. Now let's take a look at this section and using some formulas that make life easier. I'm going to stop the video. If your screen gets blurry, please let me know when when I turn off the video. It's normally it gets better. All right. So if the function, we start with the easy one. If the function is a constant, for example, y equals 5, 10, or 1/2, you name it. As you know, if we graph this as a horizontal line, and the slope of any horizontal line is what? The slope of any horizontal line is 0. So look at the graph. This is y, or f of x equals c. This is the y-intercept at 0, comma c, and you know that the slope is 0. Okay. Now, this is the proof visually by the graph. We can also use the definition and prove that. So because f of x is the constant x, f of x plus h or f of x makes no difference. Both of them are c. C minus c is 0. And it's important to understand, class, the denominator is really not 0. The denominator is approaching 0. So 0 over h is 0 over a number, and therefore is 0. And this way, we also prove that derivative of a constant function is 0. The next thing I want to do, I want to look at the exponential functions. And one of the things I want to mention, what we had seen in algebra, starting with the compound interest. I hope you remember that this is a compound interest formula. A is P times 1 plus R over N to the power of NT. A is the amount we end up with. P is the principal, the amount we spend, okay, or invest. R is the rate, 5%, 2%, 3%, and N is the number of compounding per year. So normally it's annually, so N is 1. If it's semi-annually, N is 2. If it's quarterly, N is 4, and so on and so forth. Now, if you remember, if it's continuously, okay, then it becomes P e to the power of RT. Okay, class, the formula becomes P e to the power of RT. And what we did in algebra, we replaced R over N. We let R over N be 1 over M. That means N over R is M. Okay, so take a look at what happens. If we write the reciprocal of this as M, again, I'm going over algebra that you have seen in college algebra. In pre-calculus, we use this to mention the meaning of E. So now, if you do the cross product here, class, okay, N equals R times M. So we are going to replace this N with R times M, and therefore we can write it in this fashion. You can write the M and then R out, R times T. Why are we doing that? Because in algebra, we use this process to show this becomes E, of course, when M becomes large. If it's repeatedly larger, that means M goes to infinity. And this was compounded continuously. Again, none of this one, and this one, all of them are in algebra. None of them is brand new, which means we showed in algebra E is this, okay, as M goes to infinity. So here's the definition we used in algebra. E is represented by this expression as M goes to infinity. The limit as M goes to infinity of 1 plus 1 over M to the power of M. So this was proved there. Now, if you replace the 1 over M with something like H, for example, okay, so when M goes to infinity, H goes to 0. So class, let me just write it underneath so you see what I'm talking about. If you let 1 over M be H, so what happens? Okay, so I'm replacing 1 over M with H. So if I'm changing that, so this M changes to 1 over H. And then since M goes to infinity, H goes to 0. Do you see that? So this version or this version, and all of them give rise to the number 2.71828. It continues indefinitely. And that's the definition of E, and it's equal to this number. So it's not missing, okay? It has been, they have come up with that, mathematicians. Now, so this is the definition I mentioned from algebra. This is the definition we're going to look at it today from calculus. We look at the proof of that. Again, you're not responsible for the proof, but at least, you will be exposed to it. It's not too bad. The next thing I want to explain is a lot of formulas here, starting with the power rule. And the power, the derivative of x to the power, and this is one of the most common rules in calculus. You bring the n in front and you make it a coefficient, and then you take down the exponent by 1. Now, using that gives rise to the derivative of x is 1. By the way, ddx, we're using the Leibniz notation. So the derivative of x is 1. This one says if you have a constant, you can take it out. These two say if you're differentiating, you can do them one by one, term by term. That's really the idea between the sum and the difference. And so there are a lot of formulas here I want to discuss. The derivative of a constant is 0. This is the power rule. The derivative of e to the power of x is itself. We will look at that. The rest of them are trigonometric functions. We don't come across all of them often in this course, but at least these two we need to know. And for us to prove that, we need geometry, trigonometry, a lot of information to be able to do that. So I'm not going to go over that, but I will go over the proof of this later on for you. Okay, so let's take a look at this power rule. Again, you're not responsible for that. If you can follow it, it helps a little bit. Okay, class? Understanding how we arrive at it, because in order for you to use this, everything has been proved. Okay, so for example, the derivative of x to the power of n is nx to the power of n minus 1. And to prove that, we start with the function f of x equals x to the power of n, and we write the definition. Everybody remembers the definition, class. Okay, so that's really not a big deal. Okay, and now plug in. So I'm going to plug in x plus h makes this x plus h to the power of n, and so forth. Now I'm going to basically hold on to this, and I'm going to expand this one. When I expand this one using binomial distribution, this is what I get. I'm going to explain this again. This is from algebra. We have done this algebra. I'm going to just refresh your memory. And the formula is the following, class. When you have x plus h to the power of n, okay, you get c n0 x to the power of n plus c n1 x to the power of nh plus c n2 x to the power of n minus 2 h squared. Notice the exponent on x and the exponent on h, they add up to n. And the last one is cnn h to the power of n, or you can say x to the power of 0, h to the power of n. Now, so what is that c? I hope you remember that. I'm going to write it up here. CNR is n factorial over r factorial times n minus r factorial. This is combination of n choose r. And when we go through the process, this number becomes 1. This number becomes n. This number cnn becomes 1. And that's why we have a 1 here. You see that? We have n here. Do you see that? We have 1 here. And so x to the power of n minus x to the power of n cancel each other. We write the rest of it. Okay. Now, I hope you realize everything in the numerator has h. So this, we're going to divide everything by h. This one, h goes away. This one gets h to the power of 1. The next thing, all of them have h. This one, h to the power of n minus 1 divided by h becomes h to the power of n minus 2, and this becomes h to the power of n minus 1. All of them have h except the first step. So you replace the h with 0. Everything goes to 0 with the exception of the first term. Again, this is the proof. If you follow that, more power to you. If not, don't worry about it at all. Just make sure you remember the derivative of x to the power of n is n x to the power of n minus 1. So on this page, we are going to use that. So again, we refresh everyone's memory. The derivative of constant is 0, and x to the power of n, the power rule, n x to the power of n minus 1. So quickly, I want to discuss the first one, and then you can answer me for the next if you're interested. 6 becomes the coefficient, then x to the power of, now you take it down by 1, 6 minus 1. So I hope you see that. Does that make sense? Everybody okay with that? Okay. So having said that, let's look at part B. What do you think the answer is for part B? Anyone? What happens with part B? 1,000 sits in front, and then the exponent goes down by 1, becomes 999. Right? Make sense? Okay. pay attention to the fact that in part C, your independent variable doesn't have to be X and it's not. Okay, so the independent variable is whatever they tell us to be. In this case is T. Okay, so 4 sits in front and then T cubed. Now, on purpose, not only I'm going to write y prime, I'm going to write dy dt because this is a Leibniz notation. I want to make sure everybody understands the independent variable is T, doesn't have to be X all the time. Doesn't have to be X all the time. Okay, class? That's extremely important. Okay, now if we look at the next one, the independent variable is R. So 3 times, I hope you realize this is 2R, so it gives you 6R. So I'm going to write it if it helps. So I'm going to write y prime is 3 times 2R. So if you need to take this step, by all means, I don't think you need to take that step, but it's absolutely up to you, okay? It's absolutely up to you. All right, so having said that, what happens in this case, it's 10 times 6x to the power of 5, which is 60x to the power of 5. Again, I'm going to write it in case. So it is 10 times 6x to the power of 5. Do you have to do it in 2 shots? Not for a simple case like this. It is absolutely your choice, everybody. It is absolutely your choice. I hope you're comfortable with that. So let's give everybody a moment to do this question, which is a bunch of terms, and all you have to do it term by term. Okay, class? So try to do this simply term by term. Okay, so term by term. Let's see what we get. Okay. X to the power of 8, 8x to the power of 7, plus 12 times 5x to the power of 4 makes it 60x to the power of 4, minus 4 times 4x cubed. So let me write that at top of it, class. So this one gives you 5x to the power of 4, so times that. This one gives you 4x cubed times negative 4. This one gives you 3x squared times 10. Do you follow what I'm saying? And of course, the next one is minus 6x gives you minus 6, and a constant gives you 0. Okay, so that's how it works. I hope everybody is comfortable with that. Okay, there is really not much to that. Okay, so I'm hoping that we have no problem with this question at all. Let's go to the next one. Okay, class. Okay, now notice what happens here. In this case, we are dealing with the situation that we want to use the power rule, but just the way it is, we cannot. So what do? The first one is very straightforward, is 5, but this one has to be changed. To what? 2x to the power of negative 1. If we see that, practically we are done. So first algebra, take a look, algebra. Now we go with calculus. 2 times negative 1 is negative 2, x to the power of minus 1, which is negative 2. So this is calculus. Rewriting it is again algebra. I hope you see that it was algebra, calculus, algebra. So many steps of algebra. Okay, and parts is very straightforward. 7 times 2x. This gives you 2x. 7 times 2x is 14x. And all of these questions, I hope you remember, we did it in the previous section, but why am I putting it here? I want to show you that how fast you can come up with the answer here. That's really the idea behind this. All right, let's look at this question. How do we do that? again, just the way it is, we cannot use the power rule. We have to make a certain change. We are going to change this to x to the power of 1/2. Now, when you multiply it by x, becomes x to the power of 3/2 plus 5x minus 2. Again, the reason why is very simple. A to the power of m times a to the power of n is a to the power of n plus n. The exponents 1 and 1/2, they add up to 3/2. Okay. Okay. Then what happens? Let's differentiate as follows. 3/2 sits in front and then it goes down by 1. So 3/2 x to the power of 1/2 plus 5. Okay, remember, -2 gives you 0, so you don't have to worry about that. Now, practically you're done, and that's okay. But if you want to go back to the format that was given, this is square root of x. Remember that? So that's in case. Okay, everybody. Now, I'm going to ask you a question. How about this one? What do you think this is equal to? We are looking at the derivative d dx. We want to differentiate pi squared. We want to see what the answer is. So what do you think we get? Anyone? I hope you realize that what you're dealing with is a number. And the derivative of any number or any constant is what? 0. So what you're dealing with is a constant and the derivative is 0. The purpose of this question was just to make sure you realize if I am changing this to 10 or 10,000 or e or pi makes no difference. It is a number and the derivative of any number is 0. Okay. All of these questions are in the form, just the way it is. We cannot use the power rule, so we are going to use our algebraic techniques to change them such that the power rule can be used. And for example, this is the easiest one, x to the power of -5. That's the first thing. So if I want to differentiate that, what do I get? -5, x to the power of -5 minus 1, which is -6. I'm done with calculus. And here's my algebraic technique again. Okay, everybody? I'm done with algebra. I'm done with calculus, and here's algebra. Part B, I want to rewrite that. Part B, I want to rewrite that such that I can use the power rule. So what should I do? We would rewrite it as 2/7 x to the power of -3. If we can see that, practically we are done. Okay, class? If we can see that, practically we are done. Okay, now what do we get? So let me write the answer up here. F prime is 2/7 times -3. X to the power of -4, which gives us -6/7, right? -6/7. Let me just write x to the power of -4, and now that goes down. Okay, you don't have to take that many steps. I would go from here to here, but it is your choice. Part C, again, I can't use it just the way it is, the change. I hope you see that this is 2/9, and this is x to the power of 5 minus 9, or x to the power of -4. So as long as we see that, then it should happen. Okay, now it should happen. Meaning, let's write the f prime at the bottom. Let me use a different color. So therefore, f prime becomes 2/9 times -4 x to the power of negative 5. So, which is negative 8 over 9. Okay, class? Now, negative 8 over 9 and x to the power of minus 5 goes down. It becomes x to the power of positive 5. X to the power of positive 5. So I hope everybody's okay with that. Okay. All right. Let's look at the following. Again, we have to do our algebraic technique to make this happen. To do so, this one you have seen. Okay, you've seen it many times. So this is x to the power of 1/2. So f prime is 1/2 x to the power of 1/2 minus 1. 1/2 minus 1 is negative 1/2. So 1 over 2 x to the power of positive 1/2 or 1 over 2 squared of x. It's a very straightforward process, everybody. Okay, it's a very straightforward process. I hope you are comfortable with that. So I have one step of calculus and a couple of steps of algebra. We do the same thing for the next one. We change it to 2 times x to the power of 4/5. And now we can find f prime. I'm going to put it up here, is 2 times 4/5 x to the power of 4/5. Let's write it down. Minus 1, which is negative 1/5. Okay, so we have 8 over 5 x to the power of negative 1/5. It goes down, becomes x to the power of 1/5, and you can write it as the 5th root of x. At the very least, get rid of the negative. It's not acceptable as far as I'm concerned, okay? Get rid of the negative exponent. When you're doing part F, I hope you realize because the denominator is one term, you can do the division. Even if it wasn't a term, it was like square root of x, you could still do that. So if I divide these two, it gives me 10. If I divide these two, gives me minus 7x. This is your algebraic technique. Now f prime is simply minus 7. I hope you see that if you don't use your algebraic technique class, this becomes a drag and it becomes very difficult. But honestly, with your algebraic techniques, it's a piece of cake. Okay, it's a piece of cake. Okay, I hope everybody is okay with this. All right, so we've practiced a lot with various types that become power rule, okay? We want to find an equation of a tangent line. We've seen this many times before. The difference is now we're going to use the rule and it makes life easier. Let's do that. We need two things, everybody. First, we need a pair. 4 is given. What is the y coordinate? Can anybody tell me? What would be the y coordinate? Plug in, and that's your y coordinate. So in other words, as I've said it before, you don't have to be given the pair. As long as you're given the x coordinate, you can figure out the pair. Okay, so that's the first thing. The next thing, we need to find the slope. In order to find the slope, we need to find f prime. F prime is an easy case. This is 2x minus 3. And now this is not the derivative. This is not the slope. This is the derivative function. What is the slope of a tangent line? Plug in 4. 2 times 4, 8 minus 3 equals 5. So that is your slope. And now we use, of course, the good old point slope. We've used it many times, so I hope you remember it. Y minus y1 is m times x minus x1. That means y minus 3 is m, which found it to be 5, times x minus x of 1, which is 4. And obviously, you put it in slope-intercept. Also, assuming your slope is right, the pair that works for the original function must work for this tangent line as well. We want to find the point or points for which the tangent lines are horizontal. In order to answer this question, first and foremost, we need to know what's going on with horizontal lines. In other words, what is the slope of any horizontal line? I hope you remember that. We've been over that, right? Any horizontal line has a slope which is 0. So if we take the derivative of this function and set it equal to 0, we got the answer. So the derivative is 3x squared minus 6x. Again, remember these questions, all of these questions, you guys have them. So we are looking at the solutions step by step. And so 3x squared minus 6x, that's f prime of x. Because horizontal lines have 0 slope, let's set this equal to 0. Solve this equation by factoring. Take out the 3x. Either x is 0 or x minus 2 is 0. So x is 0, x is 2. Now, what is important for you to realize, this means there are 2 points, and it doesn't mean the pair 0, 2. What it means, 0, you plug it in, and it gives you 0, 5. 2, you plug it in, gives you 2 cubed, which is 8, minus 3 times 2 squared, which is 4, 12. So minus 3 times 4 is 12, 8 minus 4. Okay. 8 minus 12 plus 5, and that is positive 1. So you plug in 0, gives you this pair. You plug in 2, gives you this pair. Now, if you're solving this most of the time, this is good enough. If it's not, you have to come up with the pair. It is the reason I write the pairs, because I don't want anybody to be under the impression that when you find this, this is a pair. No, there are 2 different points. 2 different points. All right, let's look at the exponential function f of x equals a to the power of x, and let's find the derivative of this exponential function, okay, using, of course, the definition, okay. So if we use the definition, what happens here, okay? Basically, you get a to the power of x plus h minus a to the power of x in the numerator. The rest is very straightforward. So that's what you get. You don't, I mean, you really need to recognize this means a to the power of x times a to the power of h, but if you don't write it, it's fine. What matters is that between these two, I can factor out a to the power of x. Therefore, we proved f prime of x is this. So f prime of x is this, everybody. F prime of x is this, and that's what matters. As long as we understand this is the case, we are in good shape, okay? All right, now what do we do? Here's what's gonna happen. Assume there is a number, or better yet, what if there was a number, a, some number a, we don't have the a, such that this would go to 1. If that number existed, what does it mean? That means f prime equals a to the power of x. What does it mean? F of x equals f prime of x equals a to the power of x. So mathematicians have been looking for that number. By the way, for the sake of argument, if you replace the x with 0, okay, that represents the slope at 0, and that is f prime of 0 times a of x, okay? But that's really not what matters. What matters, I want you to see the following. Okay, so you can ignore that. Look at this table. Mathematicians notice that this expression, okay, if they replace the a with 2 and let h go closer and closer to 0, this goes closer and closer to 0.7, roughly, or 0.69. If they choose number 3 and they let h go closer and closer to 0, then this seems to be going to 1.1. So what does it mean? That means we want 1. This is equal to 1, no. Is this equal to 1, no? But there is a number in between, which is, of course, closer to 3 than 2. And they found that through more numerical analysis, and that is about 2.71828 and so forth. So it gave rise to another definition for E. So E is such a number that this limit is equal to 1. So here's the definition, class. E is the number such that this limit class, you replace the A with E, must be equal to 1. That is the definition. Another definition for E. I hope you see why it's that important. And so you can, this is a point of view of a calculus and so on and so forth. What really matters is that E is not missing. E has those definitions that were discussed. Okay. We had this definition in algebra, this definition in calculus. This also, is proved in calculus as well. And it is not missing. It's just like pi. It's an irrational number. What matters for you is this: the derivative of e to the power of x is itself. That's all that you want to be concerned with. So as an example, we want to look at f of x equals e to the power of minus x, and we're going to differentiate it once and then twice. And again, we are using the formulas here that we have seen. So differentiation. The derivative of e to the power of x is itself. Minus x gives you minus 1. So that's it. That's f prime of x. Now, f double prime, that means higher derivatives. That means differentiated again. I'm going to differentiate this again. So this gives me the same, e to the power of x, and this gives me 0. So simply e to the power of x, and I'm done. In fact, if I said f triple prime, that means differentiated again. The answer is itself. Okay. We use different primes, and then normally we stop at 4 and change it to bracket and a number in between. But as far as you're concerned, normally first and second derivative is good enough. Let's look at a couple more examples in this page. So y equals sine t plus pi cosine t. We want to differentiate this. Okay. First, pay attention to the independent variable, which is t, and therefore do not write x or anything else. One by one. The derivative of sine, you know it's cosine, so this is cosine t plus pi times. The derivative of cosine is negative sine, so plus pi times negative sine, which makes it minus pi sine t. Okay. So I hope you see what happened here. I hope everybody's comfortable with that. This one, we will change this to t to the power of 1/4. And if it helps, you can rewrite this one as negative 1/2 cosine t. It might help. Okay. So again, we are using algebraic technique to make it possible to use what? The power rule. So this is 1/4. T to the power of 1/4 minus 1, which is negative 3/4, minus 4 e to the power of t. Then minus 1/2 times cosine gives us negative sine, so minus 1/2 and minus gives you plus 1/2 sine t, or you can write it as sine t over 2. We are done with calculus. This is algebra. This is calculus. One more step of calculus. I hope you realize that this is negative 3/4, everybody. And it goes down, becomes positive 3/4. Or the 4th root of t cubed. In other words, this first maybe you have to write it as a 4t to the power of positive 3/4. Even if you left it as that, that's good enough. The rest, they don't change. And please understand, this is the same as writing 1/2 sine t. You don't have to, but understand they're the same. All right, we want to look at the last page. This is a question that we have seen before with the difference that now we can use the easy way out. The distance in meters of an object is given as s of t is 2t squared minus 5t plus 4t, where t is time in seconds. What is the velocity of the object from 2 to 4 seconds? That's the average velocity. We have done this already, class. So s of 4 minus s of 2 over 4 minus 2. We did this, and we came up with 7 meters per second. Basically, it means plug in 4, 52. Plug in 2, 38. Their difference, divide by t sub 2 minus t sub. Why am I giving you this question? Because actually, the part B, I want to show you how fast now you can come up with the answer. So first, instantaneous velocity. Even if they don't say instantaneous, they want it after 1 point in time, it means that it's a simple differentiation using the power rule. So 4t minus 5. Okay, v of t or s prime of t is 4t minus 5. Now I'm going to plug in 6, and it gives me 19 meters per second. What is it that we are adding? We are adding the acceleration. Acceleration is defined as the derivative of the velocity or the second derivative of the position. That is the definition. And the reason we didn't do it last time, because now we can take the easy way out and use the formula. So what is the acceleration? We are going to differentiate this. V prime equals S double prime equals 4. Now, because 4 is independent of the t, after 6 seconds or 10 seconds or 2 seconds makes no difference. It remains unchanged. The only thing I want to add, I want to explain about the units, why meters per square second. If you look at A is defined as V prime, that means dV divided by dt. So that means the units of velocity, which is meters per second, divided by units of time. So it becomes meters per second, or meter per square second. The units of acceleration, for example, the g-force is 9.8 meter per square second. Okay, so that's why meters per square second. Finally, when does the object reach a velocity of 31 meters per second? Well, velocity set it equal to 31. Let's do that. So when we do that, we move the negative 5. We make it positive 5. So we divide 36 by 4, and it gives us 9. And the units 9 seconds.